This video explains conveyor modeling. Import a CAD file into the 3D world by the following steps. Select the Home tab, click Geometry in the Import group. Select Conveyor Geometry.3ds in the window, and click the Open button. In the Import Model window, select Collapse to Feature Tree and -X of Up axis. Click Import to import the CAD file. The imported component inherits the CAD file name. Change name to Simple Conveyor in the Component Properties window. Save the component as follows. Select the Modeling tab and click Save As in the Component group. In the Save Component As window, select Conveyors from the pull-down selection of Type and click Save As. Set the save destination to the My Models folder and click the Save button. Change the component origin to the start point of the conveyor as follows. Measure the distance from the current origin position to the start point of the conveyor. Select the Modeling tab and click Measure in the Tools group. In the Measure window, select Origin of Snap Type. Click the conveyor to select the origin position. In the Measure window, select Edge of Snap Type. Click the lower corner of the conveyor leg on the right side to measure the distance. The measurement result can be checked on the 3D world and in the Output window. Click an empty space on the 3D world to exit the measure mode. Click Move in the Origin group. In the Move Origin window, select Parent of Coordinates and enter -1031.601 for X and 227.057 for Y. Click Apply to move the origin position. Decompose the conveyor geometry features into parts. Select the Modeling tab, click Tool in the Geometry group, and select Split. In the Split feature window, select Set from the pull-down selection of Split Level. Select the first roller at the start point of the conveyor. Click Split in the Split feature window. The roller was split into a new geometry feature. Change name to Rollbars in the Feature Properties window. Split the side rails in the same way. Select the Modeling tab, click Tool in the Geometry group, and select Split. In the Split feature window, select Set from the pull-down selection of Split Level. Select a side rail, and select the other side rail by holding down the Control key. Click Split in the Split feature window. The side rails were split into a new geometry feature. Change name to Side Rails in the Feature Properties window. Split the conveyor legs in the same way. Select the Modeling tab, click Tool in the Geometry group, and select Split. In the Split feature window, select Set from the pull-down selection of Split Level. Select a conveyor leg, and select the other conveyor legs by holding down the Control key. Click Split in the Split feature window. The conveyor legs were split into a new geometry feature. Change name to Legs in the Feature Properties window. Delete collapsed_0, which is the original geometry feature. Set the number of rollers according to the length of the side rails by the following steps. Select Simple Conveyor in the Component Graph window. Click Properties in the Properties group, and add a real number property. In the Property window, set name to C-length, quantity to distance, value to 1000, and constraints to 1000 to 10,000. The range of property value can be limited by setting constraints. Click Features in the Geometry group and select Linear Clone. Set Count to C length /100 and Step to 100 in the Feature Properties window. Count indicates the number of rollers and Step indicates the interval. The value in count is divided by 100 to place the rollers at 100 mm intervals. Vector 1, 0, 0 of direction is in the order of x, y, and z. Set 1 in the direction that you want to increase the number of rollers using the clone function. In the feature tree, move roll bars under linear clone. You can check that the rollers have been duplicated. Make the side rails longer or shorter according to the C length value. With root in the feature tree selected, click Features in the Geometry group and select Transform. Enter TX 100.SX C length -200/2800.TX -100 in expression in the Feature Properties window. In the feature tree, move side rails under Transform. You can check that the length of side rail has been changed. Change the position of conveyor legs according to the length of side rails. Select the Modeling tab, click Tool in the Geometry group, and select Split. In the Split feature window, select Set from the pull-down selection of Split Level. Select a conveyor leg on the end side, and select the other conveyor leg by holding down the Control key. Click Split in the Split feature window. The conveyor legs on the end side were split. Delete the split conveyor legs. Duplicate the conveyor legs on the start side using the clone function and place them according to the position of side rails, which have been shortened. Click Features in the Geometry group and select Linear Clone. Set Count to 2 and Step to C length -100 in the Feature Properties window. In the feature tree, move legs under Linear Clone _1. You can check that the conveyor legs have been duplicated according to the side rail length. Let's check that the number of rollers, side rail length, and conveyor leg position are automatically updated by changing the value in C length. Operations to configure conveyor settings using the Conveyor Wizard are as follows. The Conveyor Wizard automatically creates the functions required for conveyor settings. Select a conveyor component in the Component Graph window. Select the Modeling tab, click Wizards in the Extra group, and select Conveyor. In the Conveyor window, click Create Conveyor Behaviors. You can check that path and interface have been added under Behaviors. Click Frame Types on the toolbar of the 3D world, and select the checkbox of frames to visualize the frame. Select Path Frames _1 in the feature tree. Path Frames _1 is a transform feature that affects the path frames under Path Frames _1. In the Feature Properties window, write an expression to scale a path frame along the x-axis according to the value obtained by dividing the current C-length value by the C-length value of when the wizard is used. Since the C-length value of when the wizard is used is 3000, enter SX C-length /3000. If the frame at the start point of path frame _1 does not move to the start point of the conveyor when the C-length value is changed, set an offset in the x-axis direction. In such case, write the expression as follows. Tx minus C length value of when wizard is used /2 plus C length /2 dot C length /C length value of when wizard is used. The conveyor settings have been completed. Connect to other components and check the operation by the following steps. Select the Home tab. Expand models by type and select feeders. Place shape feeder into the 3D world by double-clicking or dragging and dropping it. Select PNP and connect it to the start point of the conveyor. In the Component Properties window, select the Default tab. Select Color Palette from the pull-down selection of Product. Expand Conveyors under Models by type in eCatalog and click Visual Components. Place conveyor into the 3D world. Select PNP and connect it to the end point of the conveyor. In the Component Properties window, select the Default tab. Set conveyor width to 800. Perform the simulation and check that pallets generated from the feeder flows on the conveyor. Reset the simulation. Expand Conveyor Utilities under Models by type in eCatalog and click Visual Components. Place Conveyor Sensor into the 3D world and connect it to the center of the conveyor. The sensor is automatically connected to the path. This is the end of the explanation of conveyor modeling. Thank you for watching.